Hello, Johan.
Hello.
Yeah, it was a nice intro, wasn't it? So
Yeah.
first try for me. So,
Okay.
so welcome, Johan Stenström, from what should I say, iot-ab or Sensor Online, or what company do you represent here?
Actually,
all of
we have a couple of different companies here. One is IoT application and hardware. Another one is Node-Ledge, and a third one is Sensor Online. So I will present the differences later in this presentation.
Oh, very nice. So it's as we've already seen in this course, it's a lot of applications, and also apparently there is a lot of companies. And even if you have one person, you have several companies. So it's the area of IoT. So you're invited here today, and I'm very grateful that you have agreed to join. So you will, as far as I understand, show a little bit about your platform, which differs a little bit from what we have seen before. We were hosted by DataCake last week, and you have an on-premise platform that might be more like business focused, own your own data, as I understand it.
Yeah.
So, which is very, I guess that's very important nowadays, isn't it? So
perhaps you would like to have your sensor data behind your firewall if you are working within the field of industrial automation. Companies don't want to have ports open in the firewall, so they would like to have the software on their own server. And
yeah. That's a good point. And I did read a little bit, just short, on your background, but it seems that on LinkedIn. So, and you have been, I see, I'm very impressed. So you have a lot of companies behind you, and you have a lot of experience in this area. But it seems that you have been working a lot with automation and electronics. So,
Yeah.
and now I'm counting probably more than 10 different things in your career. And now you're in IoT, and now you're like running your own business for how many years? 5 or 10 years, or?
We started 10 years ago with a company
Yeah.
called GPS Logic, which was all about fleet management, also some kind of cloud-based solution with sensors connected to GPS trackers and move the data to the cloud. 3 years ago, we started to look into IoT, wireless sensor, not GPS, but from my experience within the industrial automation world, I thought it was really interesting to combine wired automation system with wireless sensor data. So we have several solutions in place how to bring LoRaWAN sensors into Scada systems and PLCs and devices like that.
Yeah. So your approach is like you're coming from where everything is run by wire and very industrial focused like applications, and now you're, as you said, 3 years ago, starting to combine that with the like IoT.
Yeah.
And wireless. So yeah.
If you think about it, the large consumers of sensor and sensor data is the traditional automation world. Then there was LoRaWAN and Sigfox and BIoT, but we tried to move wireless sensor data into their traditional Scada system.
Yeah.
But for customers who doesn't have a Scada system or another existing platform, we have also Sensor Online.
Yeah,
which
you might want to explain what a Scada system is.
Yeah, if I can share my screen.
Yeah, absolutely. Yeah, we have the screen up here. Yeah.
Yeah. So if you take a look at this picture here, you see this man sitting here in a control room. He has a Scada system in front of him. So all the wired sensors are collected up there, and you can follow a process, industrial application or something like that, monitoring what's happening. You receive alarms there, and of course, this type of installations are very, very expensive. Could easily cost 5-6 million euro, something like that, and it's costly to use electrician and cables and stuff like that. So if you can move in some wireless sensor data into their platforms today, mostly within that building where this process is going on, there is wired sensors. But if you look at water treatment, which is a geographical, a very large system, then it will become very interesting to bring in measurements of flow and depth and pressure in the water treatment. And of course, they are good payers because they are used to pay good money for their sensor data. So it's very interesting to be in this segment.
I suppose it is. Could you maybe please zoom in your web browser, make it bigger? There are people asking for this, so you can probably make it even bigger. It can't be too big, I think. So that's super. Yeah, great. It's better to scroll around than so people can see. So Scada systems, and that's really interesting because that is nothing that is what I say. Scada is not a part of this course. We're talking about IoT, and but it's interesting that this is probably one of the things that happened way before IoT, and still is happening when we're talking about Scada. So. Very early in the course, we talked about IoT and what IoT is and the definition of IoT, and it becomes really blurry. So what's your take on what IoT is? What do you think an IoT device is?
Well, it should be wireless. It should be low power, battery operated. And it should be connected over a gateway or a cellular network to some kind of cloud service. Yes.
Yeah, but that's more or less what I think the general idea of IoT is. So often it is when actually it's not a clear definition. It might, we discussed this. I mean, is it an IoT device if it's not wireless? Well, yeah, it could be, absolutely. It still could be a thing that is connected to the internet. Does it need to be battery powered? Well, depends on which definition you use, but well, I think I agree on your explanation that when you generally talk about IoT today, we talk about something that is battery powered and also wireless. That's generally what we're talking about. So, yeah. So, and maybe I didn't ask you to introduce yourself. So, if you want to, you might want to do that on yourself. So, please, Johan.
Okay. I'm 56 years old. I've been working with automation for approximately 30 years then. I own those company I was talking about earlier. I don't do all the coding myself, so what I'm about to present here, you have to be kind and don't ask too many specific questions because I can't answer them. I have good people employed here, which is more or less magicians, I think. So first they say we can't do it, and 2 days later they say it's done.
Yeah, and you are going to show a little bit about your platform, and I've actually not used it. You have shown it for me, but I must say that I'm impressed, and let's see if you're going to demo a couple of things for us. So we'll just get straight to it, I guess. So we can see the screen now. So
What's unique with this platform is that we allow it to be installed at on-premise at customer servers. It is a multi-tenant platform, and it's also multi-language. So let me go down here and really quick to some kind of try to explain what you see here. On the left down here, you will have a lot of different LoRaWAN server softwares and providers. There is the Things Network, Things Industry, Helium, PingDay, ServerNet, Netmore, and all of those.
And PingDay is Statssubsalliansen, isn't it?
Yeah, they changed name recently. So we can, if customers is operating their sensors in this net, we can receive data and help the end customer to visualize and do alarm handling reports and all of that. We should soon be looking at that. There is also a built-in LoRaWAN server software in this platform, which allows you to have your own gateways also. So if you for some reason don't want to go this way and you want to use your own gateways, that's possible. Then all of this data, sensor data, is arriving at the server installation, and there we have an automatic payload decoding engine, which supports about 300 different sensors today. This meaning we are hardware agnostic. We can use hardware from many popular brands, and we can also use data from private gateways, but also from LoRaWAN server network operators. So you choose. Once the sensor data has arrived in the payload decoder, it do a couple of different things. It contacts our REST API, which looks like this. You can
and that's the documentation that we see here is something that you can find like online.
Yeah. So it's those rows here, which is colored. It's called endpoints, and we have over 100 different methods of exchange data with the platform, not only for our needs, but also for third-party applications that want to get or use our platform to visualize data. So it's two ways here. So you programmatically log in here, you receive an authorization token, and with that you are authorized to use these methods and store data. Let's go back here. Once we store the incoming sensor data in the database for traceability, timestamped sensor data, just record by record. We also publish the decoded sensor values on the MQTT broker, meaning that third-party applications who wants to receive, they can subscribe to sensor data here. And we also have support for industrial protocols called Modbus TCP, Slave, and OPC UA. That is the key to move sensor data into the industrial automation world, because this is protocols that they are using.
Yeah. So what we're seeing here is that you have a lot of different integrations with like whatever sort of.
Yeah.
And if I read correctly here from your picture, like on the left hand on the built-in applications, I see HTTPS, MQTT, COAP as well. So you can actually connect this to, as I understand it, whatever you want, more or less.
Yes.
Yeah.
And then we have no-code IoT portal, drag and drop user interface, end user real-time dashboard, user management with roles and permission, sensor management, rule and script engine. Alarm is triggered and sent by SMS and email. Data storage and traceability, multi-tenant architecture, very important. The customer who is installing this as a master license have the ability to bring on new customers on their servers and earn money. Report engine, yes. Modbus for OPC for Scada integration. Private or public dashboard, meaning we can create dashboard here and share it, the link to, and then the menu system is ripped off and you can just look at the data, but you can't change anything. Software is misspelled, is multi-language, and we also have a responsive web design here. So the site will look good on iPhone, Android, tablets, and PC and Macintosh and so forth.
Yeah.
And we also have a built-in field tester, LoRaWAN coverage map. I will show you how that looks elaborate later. So this is schematics, what's going on, and we can have a look here at the application server. It has a URL here, decoder.sensoronline, and we can see what's going on.
Maybe you can make this picture a little bigger, so it's a little bit hard to see. So
yeah,
that's great. Thanks.
Yeah. So what we see here, the actual application server is running as a service, and with webhooks we can connect to the service and get the sense of what's going on here. So here we have a device EUI. It has been sending this raw payload, which is translated to these values. It's an ELSYS, and it's been coming in there over HTTP. Could be MQTT there or co-op.
What's your take on choice of protocols? So when you're talking about HTTP, REST APIs, and MQTT, COAP, etc. So if you can just prefer one protocol, so this is the one. Let's say that you don't have to adapt to whatever. Just choose yourself. What would be the best choice?
MQTT.
Yeah. Okay. Yeah. That's great to hear. Actually, in my opinion, I do agree as well. So it's super. You have a lot of functionality built into the protocol. So that's great. Okay.
Yeah. So once this is our staging decoder, so it's not much sensor traffic going on here, but we run this software at the Akademiska Hus in Sweden. We have approximately 10,000 sensors moving in this. Then there is a lot of traffic in this screen here.
So you 10,000 sensors, and you say Akademiska Hus, and then is this like several buildings, or is it?
It's all the buildings in Akademiska Hus as they have done so far.
Okay.
Yeah.
And what kind of so these devices are these LoRaWAN devices?
Yeah, it's okay. We sell them these kind of gateways sitting all over the campus area, all over Sweden now. And we also have room sensors and stuff like that, which is used widely.
That's very interesting because we have a lot of students here exploring LoRaWAN, and there is what I hear now is that there is LoRaWAN networks already, but these networks are not open. So only Akademiska Hus can use these networks.
They use it to conserve energy, to make their buildings smarter. So they use it to get a grip on the room temperatures and then adjusting the heating PID regulators in the PLCs. Yeah.
But that's very interesting because we have a lot of LoRaWAN networks which is out there which we can't see because they are private.
Yeah.
And I guess that many are. So if it's a company, you want to own your own data, then it's not that expensive to set up your own LoRaWAN gateway.
No, I usually say, how many sensors can you install with an electrician? I mean, a gateway costs, industrial gateway, around 10,000. I have the rule of thumb, 10,000 Swedish krona, 10,000 meters, and it can use many thousands of sensors. So it's just normally, as with the working labor cost and all of the expenses, 1 or 2 days with an electrician, and the cost of one gateway is consumed. So after that, you are on the plus side if you use wireless sensors.
That's very interesting because then this is a clear business case, a use case for LoRaWAN networks. So I mean, just having these very, very low cost for doing things, which was much more expensive with other technology.
Then you have this PICOM gateway, which cost almost nothing.
Yeah, I have it here as well. So it's
I've been running this for test now half a year, and it's just working. So it's perfect.
Yeah. We have got questions about that. What kind of gateway do you recommend? And I've asked this. So it's funny that you already mentioned it, because I was probably going to ask you later on. So what kind of gateway do you recommend? But then I know the answer. It's Pygate. So
No, I have a whole range here. It's Ursalink or Rock Wireless, or it depends on the customer budget and how much he wants to spend, and if it should be indoor or outdoor. So there is a lot to choose from out there, and we have our favorites, of course. Okay, so we need to move forward here a little bit, I think, because there is a lot to show here. Once data is coming in here, we can also show them. Here we have the MAC address, the temperature, the value, which must be in a freezer. And here we can expose this value in a Modbus holding register, meaning that PLC or a Scada system can now connect to this Modbus TCP slave and get those values in holding register 40,001 and 40,003. So here you can put in 40,005. Should be odd numbers all time, and press save. So this is a nice feature. Okay, so I've showed you now the REST API and the Modbus part here and the database application server, what it's doing. Let's go and log into actual customer install here. As you can see, perhaps here, I should go up a little bit in.
Yep.
There is a language tab here, so you can choose Swedish and English. So we choose English now. We provide a language file, so you can translate from English to any language in the world if you like to. So now it's logging. Today I'm going to show a specific customer case. It's about a Swedish, I'm sorry, it's not my native language. It's called mandatory ventilation control, and has to be done every 3 years, and send this protocol to the authorities to avoid getting fined. It's a very large fine here. And it's done to maintain the quality of a ventilation system, so it's over time, doesn't change, that the values in airflow and pressure remains what it once was when the ventilation unit was installed. This is of course very costly for the people who owns real estate facilities. This particular customer is called Locum, which is Stockholm hospital facilities. So it's 2 million square meters of floor space, and of course a lot of ventilation. They pay approximately 3 million euro to have people running around doing measurements and producing Excel spreadsheets nobody looks at. And they get this Excel spreadsheet every 3 years. But with wireless sensors now, no installation cost, easy to install room sensors, CO2 sensors, differential pressure sensors for filters and airflow. We can do actually this inspection every day, and we refresh data every 10 minutes. So now they can have full control over the ventilation. They have already, using this approach, done huge savings on energy in heating and cooling, because this system will immediately trigger alarm limits if it's up or down on different set points that we have defined. So
okay. Then that's like the business case here is that this is like a super clear business case for the IoT. So actually you're saving a lot of manual labor. So
yes, and we also take away a lot of labor, which they used to pay for, and now they have wireless sensors instead, which
Yeah.
become more effective and in the long run cheaper.
Yeah. And you also get a better ventilation system in the end. So
yes. Yeah, it's very important in a hospital environment that the air pressure is right. When you go to an operation room and similar situation, you don't want to have bacteria from one operation room to be sucked into another room where they are operating the ice or something. That will be a disaster. So you need to monitor the pressure. It's overpressure in those type of rooms.
Yeah. And I think I read it in somewhere that you could see actually a correlation between like the COVID infection risk and the CO2 level. So those, if you have a high CO2 level, it means that the air is too many people are in the room. So you can actually correlate that as like a COVID risk indicator as well. So that's interesting. Yeah.
Okay, so once you logged in, you come into your account. Your account consists of different. We can go through this really quick. So your account is a company. It has several users, which has different roles. You can create new users with the plus sign here. First name, last name, an email address, a phone number, and a password, and you will get an invitation email. Then a company has one or several applications. Let's say you are real estate owners. Perhaps you have different houses. You have a different application or group of sensors. Then you go into the node list. A node list is your sensors. First, you have the device AOE. You have the name, pressure sensor. You have a type of manufacturer. You see the remaining battery level. You see the RSSE value could be interpreted. How far is it from the gateway? And if it's far away from the gateway, it will consume more batteries. Or you maybe from this value can take a decision. We need to put up another gateway here. Latest value. When was it received in the server? How many data points has been collected by this over the last 24 hours? 72. It is active. It's no alarm. If I press this row now, we expand the node so you can see your different sensor values. That could be either connected on screw terminals, different sensors, or it could be a room sensors, for instance, which only reports temperature and humidity or something like that. So if we go down in this list, we will see here that we have SED. This is a radon sensor measuring the radon gas, yeah. And this is actually on service here now. So the system recognizes here that, okay, this sensor has not been sending any data. So it monitors that the data from the wireless sensor is not coming in as expected, and there will be an alarm to the guy. So this is the sensor list. Then you can add your gateways. If you want to add new sensors, you create it with the plus sign. You put it in an application. You give the 3 keys. Give it a name, latitude, longitude. You choose a decoder and create. You can also import CSV file, or you scan a barcode, QR code on the back if we deliver the sensor. So it will be automatically inserted.
But I can see here now when you put in a new sensor that you put in the dev EUI and the app key and everything in this. So you're actually also communicating with the network server, as I understand it. So this is both the network server and the IoT application platform.
Not all of them, but some of the more popular, the Things Network and ShipStack and all of those, we use their API to create them there. So you don't need to sit with a very long app key 2 times. We do it once.
Yeah, that's a time saver for sure.
Yeah. So here you have 5 different alarms defined. You have an alarm history down here, so you can see which alarm has been triggered over time. We have a few here that is in alarm state, and we can go in here and see, give a name, alarm message, which day should be active here. We also include Sunday now. Which node? This is you can choose from the nodes that are in your account. And this particular node has a few different sensors. We are interested in the CO2. And who should receive a notification if this alarm is triggered? What is the alarm limits? How long time should we wait before we raise an alarm? The value could go up and down over the trigger level, so we don't be notified if it's going over and then go down again. So we say it must be in the error state for more than 10 minutes in this case. Yeah. But you can drag in this slider and you will have a longer time. So, and this is the method you choose, if only mail or SMS or both.
Yeah. One short question here. Do you think you could try and see, because the screen sharing is a bit blurry, so I would see if there is a button here I see, and when you press share screen, share in 1080p. That, well, I think you need to remove screen sharing, and when you do that again, see if that is clicked or not. Or if you don't find it, then maybe.
Oh, I can't find it.
No, okay. Then we'll have to live with that. It's not perfect, so we still can see. So it's actually, it looks very much better now. So something you did something. So okay. Great.
So this is how you define alarms, and you can create new alarms here easily. You can also try your test email and SMS setting and send yourself a check. If everything is set up and working. Once you have defined your alarm, the software will start to monitor the sensor data and the trigger level and delay time, and it will notify you if something is wrong. Field testing we haven't done here, so I will go to another script engine we have here. It's quite interesting. We have built in a JavaScript interpreter. So you can create a new script. You give it a name, chiller control, and then you can have 3 different type of script. Looping script, and then looping script will just go with a quartz job every 10 minutes or 1 minute or whatever. Invoked script is triggered by a button on the dashboard, or triggered script when a certain sensor data is arriving at the server, you will run this script. So you will, if you, for instance, do an average, so once every those sensors arrive in the server, we will do a new average calculation. And it's 100% JavaScript syntax here. So, but we have built in a few extra features. So if we have a sensor made in US and it's sending you sensor temperature in Fahrenheit, but you live in Sweden, so you want it in Celsius, you need to convert that. So variable temp to Fahrenheit equals tags, and then you choose the sensor device CV, and then you read the key. So that is, you cut that and paste it in here. And then you can write this sensor data back to the database, meaning that now you have created new calculated sensor data based on incoming sensor data or events. So if we take some more examples here, how to use the syntax and what you can do for it, it becomes very powerful if you know JavaScript. With this, you can go outside the box we created and do other stuff.
Yeah.
Let's say many of the analog input devices are reporting in 4 to 20 milliamps or 0 to 10 volt. but the measuring range could be 0 to 1000 Pascal or 0 to 2 bar or whatever. You need to present not in milliampere to the end user, but in the I don't know the name. the actual measurement that he's interested in. So
yeah, absolutely. So you could that could also perhaps be done on the device, depending on what kind of device you have. So the preference there. So do you want to put as much of the code on the platform, or out on the devices? How do you think when you're developing something?
If you're, for instance, using the PyCom and you write your code in MicroPython, and then you do all the calculation on the chip, of course, that is most convenient. But if you need to combine one PyCom with data from another one to create the third value, then you can do it server side if you like to.
Yeah. So it's really
it's different. If you buy ready-made sensors, then you can't really go into the firmware and do anything because it's locked. Then you have to do all the calculation server side. Then we have the possibility to do reports. So this is a report lying here. And you give it a name, who should have it, what is the interval, daily, weekly, or monthly, which sensors should be included in the report. And each night, 3 o'clock, if it's daily, you will have a report in Excel emailed to you. You can also here make a report download. You can choose your own period and choose a node. And with this node, you have a sensor, humidity, add, and get. Now we instruct the system to fetch this data and export an Excel for me. Here we have different Excel templates depending on what the customer wants the report to look like. So it could be a consumption report or just raw data report. So once you have, this is very quick, but once you have your login, you can add users to your company who should be able to look at the data.
Yeah.
Then you create your applications, one or several applications, one or several nodes. There is no limit on nodes or application or users here in this system. You set up your alarm trigger, which you are interested in, and perhaps do some scripting and set up your reports. Once you have done that, you're starting to build data in the database, which you then can be used to create your dashboards a bit.
Yeah, and just actually, I got a question here now from the students. Can we use this platform to create our own projects? So
of course.
Yeah, so of course, okay.
We have been discussing this, that we should have one of these at the university.
Yeah.
So Fredrik can add sub-accounts for students to visualize the sensor data. So it's plausible. No big deal.
And I can say right away that I haven't done that yet. So what we are going to do is to work on this, and maybe we can make it happen very soon. But it is an on-premise solution. It's not plug and play with the button. We need to do a little bit of work on the back end to get it working. So yeah. So
then you can start to build your dashboard to show you the sensor data. And this particular dashboard is huge. So what we see here is room temperature. You have a set point, which is the blue pointer. You have a green here, green sector, which is in which area is it allowed to be. If it goes into red, you will create an alarm. You have CO2 values. relative humidity. You have particular matter, how much dust or particles is it in the air that we breathe. This is in Stockholm. Sometimes it's very dirty. And this is the pressure in the ventilation unit. And we can go down here. And we can see over time. You can choose time here. Presets, or you can choose your own period here. So let's say last 7 days. It's easy to change. We also created this, which allow you to have floor plans, drawings of floor plans, electrical drawing, ventilation drawings, road drawings, or whatever you need to have, to more precise put in the place where you have installed the sensor. So we have a blue dot here. If I press this one, you will see an info window here, which will show you the sensor, where you place the sensor. In this particular case, it's a differential air pressure, which is measuring the airflow in this ventilation outlet. So it will report wireless data all the time. So with the same nice feeling that you have on Google Map, you can zoom and you can have as large floor plans as you like. It's no limit. You upload your. We also have the ability to put sensor data like this. I will show you later here how we can create new data. So if we go here at the bottom, we have a blue cogwheel. This is your toolbox. If you press that, you will have a pen and a plus sign. If I go to pen, we have a pen here. Then I can start to move around stuff. I can say I want this size. It's quite easy. If I then press the pen here, I will go into the definition dialog. So I have a name here. I can change it to anything. I choose a node. I choose a sensor. I choose the range and the colors. And I can say I can have a target value. So let's do that. I have a target value. I say 800. Save attribute. So I added on this one. And I now need to refresh this page. So I do that. So I have a new target here, which is 800.
Yeah, but this kind of dashboard that you're changing, so often when you're using this platform, like the Sensor Online platform,
yeah.
I guess that Akademiska Hus, the guys or girls that are working with like the buildings and want to check up on the status, do they only have this dashboard, or are they allowed to go into the system and play around?
At Akademiska Hus, it's a bit different because they don't use this type of visualization. They also already spent millions of euros in this kind of system. So we are just decoding the values and put them in this environment instead. So it's a bit different. But if you look at a municipal, a town, there is already this kind of system in place for facilities, water treatment, central heating and cooling, and energy. They already have this kind of system. They are looking at screens like that, monitoring the process, what's going on. But if you go to other type of departments. So what you say in a Swedish municipal, let's say the park, where you look at the park, how much is in the trash bin, and those kind of applications, they don't have a monitoring system. So they want to have some kind of platform to look at the data. And of course, this is available online in your pocket. So even if you are in this environment, which is totally closed from the internet, it would be a disaster immediately if this type of system is hacked. So this is normally disconnected. But as we, in this type of installation, we put sensor online in a DMZ environment, we can move data from the closed environment to over the API in a secure manner. And then you have this kind of wired sensor data in your pocket on your vacation, if you like. So you create different dashboard. You choose if you want a chart, a trend chart, gauge, text, latest value. If the tilt sensor, we have all this type of visualization widgets that allows you to show you collected sensor data.
But may I ask, I mean, this area of IoT platforms, I know that we've discussed that earlier also in the course, is that you can, if you just Google IoT platforms, you will end up with a lot of Google Google results. So you can probably find at least 20 of them, like just on top of your hand. And that is probably not enough. You can probably find even more. And so in this area, so what you're doing, if I understand correctly, is that your platform is more focused for like the on-premise. So that's an area where you're like doing something different than many others. And
we only charge you once for the platform.
Okay.
So with no annual fee or something. If you want support upgrade year 2, that is 15% of the license. But you don't pay per month. You pay it once. And I can show you here. Go here. If you go to settings here, you have a license, which allows you how many companies you can add on your license. So if you buy a master license and you want to create your own business, you add on more IoT project application, more customers into this platform. They all share the same server with the same CPU, ROM, and hard disk, but you just add more customers to the platform. Then you have to call us, and we will do some business in between us, and you will have another license which allows you to add 1, 2, 3, 4, 5 different clients. So it's
so the business model is really like, if we look at the area, and then I guess that many of the students have already, you might have already have started to explore. I mean, we had Data Cake, and we have another platform which is ubidots. We haven't been actually showing that just yet, but I know even if we didn't talk about it last year when we had the course, a lot of the students ended up using ubidots for their project. And then we have PyBytes, which I guess, Johan, you have used as well. You're using PyCom. So, and that's also, even if it's not, it's a simple variant of the IoT platform, but you can do some visualization in PyBytes, and it's made to. So there is so many.
It's great to play around with that, but you never end up in this environment with something like that.
No, and you can't create in PyBytes. It's impossible, in my understanding, to create some kind of public dashboard or a dashboard for a customer. So if you want to build your application for someone else, you can't use PyBytes, in my understanding. So
just show you the field testing, which is an important part also. Let's say you put up a gateway. In this particular scenario, we put up one gateway in the town of Skövde in Sweden, and we want to find out what is the coverage. So then you can use this software to add a field tester. It's a device that gets a GPS coordinate and also have a button which you press. And that is transmitting data. You can sit in a car with that and press the button on this device, and it will send in location data. And that will come in here in latitude, longitude, signal to noise ratio, and RSSE value. So you collect a lot of points while you're driving around with the car to find out what is the coverage. If you click the I here, you can go on Google Map and we will plot this out. And this is a town with 60,000 citizens. And the range here is approximately 10 kilometers wide. And of course, in this area, there is a lot of industries and housing. And so if we just, which is going to happen after the vacation, here we are going to add one more gateway. And over here, we're going to add more gateway to give a better support here. But
that's very interesting, because I guess that you need to measure to actually say what kind of coverage you have. But this gateway, what you're showing here, how is it sitting high up, and what kind of antenna do you have?
We're using this one. It's a Rock Wireless 7240.
Okay, yeah.
So we like this one, or the Ursalink. It's good price performance, and
but that it's free antennas on that one. So, and is it like one is LoRaWAN and the other two are something else, or are all LoRaWAN antennas? Or
no, one is LoRaWAN, two are for SIM card LTM.
Yeah, okay.
One is Wi-Fi, and one is for the GPS antenna.
Okay, so you have everything included in that one.
Yeah.
Yeah.
And the menu system is great, and you can run the LoRaWAN server on the gateway, or you can just move it in packet forward or a basic station protocol to our.
Yeah. So when you say that you run the LoRaWAN server, you mean the network server chirp stack, or is
Yeah, it's built in on that LoRaWAN gateway.
Yeah. Okay. So that's actually a little Linux server. In a neat format. Oh, that's very interesting. So I haven't played around with that myself, but I know that if you have a Raspberry Pi and you buy a LoRaWAN extension hat, it's no problem to run both the packet forwarder and the network server on the Raspberry Pi, obviously. But that you can't do on a Pi-gate.
No.
Not that I know of.
Not yet.
Not yet.
Okay. This is, in short, what Sensor Online is all about. It allows you to build your own application at customer sites or behind customer firewalls, to run their own private LoRaWAN applications for their own purpose. It's free to set up LoRaWAN gateways. There is no special license needed or something. It's just to know what you're doing and put up the gateway and start to receive sensor data. So we are helping our customers from A to Z with everything, or with just sensors, or with the gateways, or visualization, or whatever. We do it all.
I got a question about the exact number. I think it's 7240. Is that correct? Visgate Edge Prime. So the gateway you showed.
Yes.
Yeah. Okay. Then I said correct. So in the chat. So yeah. Sorry.
We also have projects using Sensor Online that using NB-IoT or LTE-M. Then we have an interface for that too. I showed Fredrik before here. We are working with Europe's largest silo manufacturer to receive the level of grain or food or chicken food or whatever in those silos, and transmit that to. I can show you how that looks because it's quite. We land all the data in here, and we go to MAFA.
But now you're into also an interesting area. So we have talked about LoRaWAN a lot, and then I know that people are also thinking of NB-IoT, and we are going to be visited by Tele2 next week, and so we have our cellular IoT session very soon.
Yeah.
But there is really a lot of focus on LoRaWAN today, and so what's your take on communication protocols like NB-IoT, Cat M1, LoRaWAN, Sigfox? What's the hottest protocol, and where do you see things are happening now?
Yeah, in Sweden it was between Sigfox and LoRaWAN, where Sigfox is no more. Not many are using those, but they have their niche. But most of the business, if I look to my own turnover, 98% is LoRaWAN.
Okay.
Yeah, but for certain, like here, there is one end customer, MAFA Silo, which has over 1,000 silos. He cannot put up a gateway at all silos, so he needs to have a cheap way of sending information back to the cloud. So we built our own printed circuit board and connected that to a LiDAR, a type of laser sensor, and on top of that we put a PICOM and with a SIM card from Once. It's pay 500 megs for 10 euros for 10 years.
And I think that these kind of SIM cards are super interesting. I mean, actually, so as I mean, 10 euros for 10 years, and you said 500 megabytes.
Yeah.
So it's really, I mean, 10 years ahead of us. That's a long time. Many don't know what they're going to do in the next couple of years if you're going to plan your like private planning. So 10 years is a long time.
If the 500 megs are consumed, then you can add 10 more euros and you're good to go again. So it's really a great
and I think that I read, I think it was Erik, one of the TAs, that mentioned that PICOM was actually now sending this Once card for free, if I remember correct, with a GPI. So they had made so the PICOM and Once are in some kind of collaboration when they send out these for maybe not for free. Maybe I misunderstood, but that's what I saw. So it's.
So for this particular LiDAR that we are looking for placed somewhere at the farm, we can see the distance here is 1.88 meter down to the food level. And a couple of hours before that, it was 20 centimeters less. So
yeah, could you make it a little bit bigger? I think it's hard for us to see. So that's much better. Thank you.
So we need the LiDAR strength. It's how confident is the sensor on the actual measurement, and the RSSE value, what is the field strength in the cellular network at that particular, and the status is okay from the sensor. And he has a lot of sensor, this guy, and it's sending sensor data all over the place. And why are they doing this? Yeah, because it's somebody's going to fill those silos with material, and if you can save on transport, routing optimization, that means less fuel used, less labor cost, and less maintenance on the cars, and they will last for maybe another 6 months or something if you can drive smarter. If you can in beforehand see on Google Map where are the silos that need to be refilled, and is it the same type of material that should be refilled? we bring it at the same run, meaning you can plan it smarter. And all of this is done with PyCom. It's
so your choice of so this is one example when you're using the PyCom device, which we use as like the recommended hardware in this course for like a real business use case. And in action. So so I know that there are probably more examples of this. And
we build our own. Let me show you here. If we have it here, I don't know. Yeah, we build our own printed circuit board, and we upload the design to a company in China. 10 days later, DHL Express is outside my door and say, "Hey, your new PCBs are here." We insert the PyCom, and it's a great way of making money.
Yeah, that sounds great. So, but let me just ask. I mean, we talked about, and in this case, we have the cellular, the once card, and we're using cellular data.
Yeah.
And why aren't you using LoRaWAN for the MAFA silos as well? Is that
the cost? Because then we would have to have a gateway at each farm. You know, they are so far away from each other, so we can't really. We can't. It's not economical to have a gateway there. Perhaps in the future, but not now.
Yeah. So as soon as you have a LoRaWAN coverage all over Sweden, it might change very fast. Okay.
Yes.
Because it can't be that very much data you're sending, I guess. So it's as you say, you're only sending small packages. But I think when we talked earlier, we talked about the PyCom devices, and as you said, that you have 500 megabytes of data, and you want that to last as long as possible.
Yes.
So how are you managing to optimize just that kind of problem?
Well, we are only transmitting those values that you see in that JSON here.
Yeah.
This is the only data that is going into the air. But from this platform, we have a connector that is going into the visualization system for the silos. And that is a lot more complicated with authorization tokens and bank security stuff. And that will be very much data, more than we need. So we bring it in here first, with just a small amount of data, what we actually need from the silo. And then we add all of the other things in the connector, and we run that over normal internet to the customer visualization system, which is another system where you can look at what is the actual silo level.
Yeah, and if I count this correctly, you're sending this data about every second hour, if I like 2-hour interval, sort of. And if you have 500 megabytes of data, you actually could put, for 10 years time, you should probably be able to put like about 400 bytes in each message. And
we are not sending that.
No,
maybe 50 or something. So
yeah, so you really I mean, when you're talking about IoT, so it's really very, very small amounts of data that are needed to create something useful. So I had that question earlier that one was asking, do you want to put as much like code on the edge or on the server? So, and actually I did some discussions in during our talk in the chat, but my answer was it depends, and I got that same impression from you, that it depends on the application. Sometimes you might want to reduce it as much as possible, and in this case it makes no sense of sending anything extra if you need to buy yet another SIM card or like refill that for then it's a cost. So
yeah, but if you can do computing on the edge, like you can do on a PyCom, and you have all those protocols, Wi-Fi, NB-IoT, LTM, and LoRaWAN, it's very powerful. You can connect in the PCB we have designed here allows the PyCom to use Modbus RS485 protocol, and there is thousands of sensors out there that is already in the market using that protocol. So you can buy ready-made sensors and you add your PyCom card with that sensor or that or that or that. You can build something really interesting and send it to the cloud.
Yeah. So, talking about PyCom now. So, what's your take on MicroPython for embedded devices? I didn't plan to ask these questions, but I can't refuse.
I don't do the code.
You don't do the code. That's a great answer.
I stopped a couple of years ago, so I left that to my employees, who is really into that. The platform you have looked at today is made with C# and Vue, but they are in MicroPython and they do anything. And we should also hire. So if somebody out there looking for a job, if you think what you have seen here is interesting, you can contact me and we will see. We have office, but we haven't been there for more than a year now. So it works to work wherever you are. So
we are actually, I've been asked that before from others that, and we are going to put up a job announcement channel in the server. But let's make people finish the course first.
Yeah.
So, and the people are planning their projects now. So, and many have already decided on what to do. But maybe what's the most interesting thing if you wanted to, like, say that this is a super interesting area which would be super fun to make something in IoT in. So. Not something that you're already doing, obviously. If you want to put something into the students' minds, do you have?
Not really. It's you can do anything with the PyCom, for instance, and it's the best idea within IoT. It hasn't happened yet. It's we are in the start phase of all of this, and there will be a very interesting future ahead of us, I think, because we will start to measure all kind of things. And there is a lot of skilled people out there that are exploring very different areas within IoT. So it's getting hard to find areas which hasn't been explored already. It's quite easy to find the sensors with LoRaWAN that has a specific function.
There are already there is a lot of sensors out there. You can't find them in the normal consumer market just yet, but just wait and see, and we might find these sensors even as like a consumer devices in MediaMarkt or NetOnNet or whatever. We can't find them yet, but I'm sure we will. But at this moment, it's much industry focused. You find them, but it's not that easy. But I'm just thinking one for. I mean, you have these use cases which you shown here, and I'm sure you have plenty more which you might not want. You might not be allowed to mention. I know that you said that before, so let's not talk about them at all. But the thing that interests me here is that, I mean, that kind of data that is already out there. I mean, think of Akademiska Hus, that you have all these buildings, you had thousands and thousands of sensors, and there might be other cases, companies which are not involved, not projects, not at your place, but let's say that you can use all this data and create some kind of even more like data, a view of all the data. Well, there might be business opportunities in that area as well.
The sensor data with AI could be something, I think, to be exploring. There is sensors for the elderly, care of the elderly, to detect if they are, flushing the toilets. Do they open the fridge once a day? If that doesn't happen, then you better send somebody over and do a check if they are okay or not. So there is a lot of applications out there that can be used, and there is a certain behavior around the sensor, and with the AI you can start to detect patterns and see if you can gain some knowledge on that.
And also that is maybe on what we talked about earlier. If the process the data on the edge or on server side, like from the integrity and security perspective, also it might be better to process something and on the edge, because if you transmit the raw data, if you take a camera, for example, if you send that picture in raw format to some server outside, like China or US, or it can end up, then, well, obviously the analysis could be done there. But if you only process and use machine learning on the edge, you might only want to know if it's a dog or a person.
Yeah.
You're never sending anything else.
No.
Then in like the integrity perspective, you might be fine with actually installing a camera if that's what it does.
We have built sensors using the NVIDIA Jetson card.
Yeah.
To do read registration plates on cars and counting traffic, how many bicycle, how many cars is passing and stuff like that. But we also have this GDPR regulation, makes it difficult to sell a sensor that actually see people.
Yeah.
So it's it's you can do a lot of interesting thing here just to play around with. We play a lot. We play a lot at our company.
Yeah, but isn't that what you should be doing as an engineer? I mean, always make the world a little bit better and try to solve problems by doing it. So I got a question here. Would it be in the future able to see if elders have taken their pills or something like that? Yeah, I guess so. Or
yeah, of course.
Why not?
Yeah.
We could at least put a little sensor on the pill can, like the can, when you open it, and if it hasn't been opened for.
Yeah, of course. So it's a matter of the budget. Always about the budget. What kind of problems are you going to solve, and what is the customer willing to pay for it? So
yeah,
it's we will see what's happening. We are in many different projects which are in the pilot state, and we don't know if they are going to fly or not, but we give it a try.
Yeah. Okay, but I think that our time is up, so I will end the stream, and I do thank you very, very much, Johan. Stay put. After I end the stream, we can still have some after chat. So, yeah. Okay. But I'll end the stream, and I get a lot of thank yous from the students here in Discord. So
thank you for letting me be here, and for your interest, and
Great.